My name is Arpit and today I am going to demonstrate week 3 digital experiment. In this experiment I have to configure the 74LS163 IC that will produce 0002, 111 and 1112000 and how it works and explanation. So this is my ID and let's proceed with the experiment. So let's start with the experiment. So in this experiment the problem is given that configure the counter IC that is 74LS163 to count from 0000 to 111, and second is to configure that 74LS to count 1112000 and explain how it works. So first of all let's proceed with the how many component I am using in this experiment. So I am using LED and some registers, and that is IC that is 74LS163, and that is one is inverter IC that is 74LS04, and one IC is CD 40106, that is Smith inverter IC. So first of all start with this Smith inverter IC, Smith inverter IC. That what IC do is to convert the sine wave into the square wave. So I am giving the 1 hertz 5 volt frequency from the ADALM, that is channel A, to this IC, and the output pin that is 2 to go to the counter IC. And yeah, the how this Smith inverter IC it works. And second one is the inverter IC, that is in this IC there is say 14 pin IC and 6 inverters. So for the inverter I am using invert the bit to print 1112, that invert the bit and then print that will print 1112000. So and yeah, this is the counter IC as you can see in this. So let's start with each pin how it works, and how the pin, what input I am giving to how it works. So this is 74LS16 is the synchronous 4-bit counter IC, and let's proceed with the pin number 1. So pin number that is CLR, it is an active low pin, and this pin used to reset the counter to the 0 if it's active low, meaning that it will clear the counter and set to the 000. So it means if I give to the 0 volt, the counter will reset. If the clock is CLR bar is high, then counter or operate normally. Then go to the pin number 2. The pin number 2 is the clock input control that time of the counter, and that increases on the rising of the edge low to the high transition of the clock signal. Every time the clock pulse is received, the counter moves to the next count. And the pin number 3, 4, 5 and 6, pin number 3 and 6 is the LSB and MSB of the input pin, that is ABC, so parallel load input. And pin number 7 is a ENP pin, that is control enable parallel active high pin. This pin enables the counter when set high. If the ENP is low, the counter will not increase regardless of the clock pulse. To enable the counter, both ENP and ENT, the pin number 10 must be high. So, and the pin number 8 is the ground, that we have to connect to the ground. And yeah, pin number 9, that is load pin. So when load is set to the low, the binary value at parallel input A, B, C and D is load input counter on the next clock pulse. When the load is high, the counter operates normally and increment with the each clock pulse. And pin number 10, that is ENT, that I talked before. This pin used to enable the rappel Cali output, and that is ROC. It must be high for the count to increase. When ENP and ENT both are high, the counter will count with each clock pulse. And now you can see pin number 11, 12, 13 and 14, that is pin number 11 is MSB, that is QD, and pin number 14 is LSB, that is QA. So series start from LSB, that is QA, QB, QC, pin number 14, 13 and 12 and 11. So that is the output MSB output pins of the 4-bit binary counter. And the pin number 15 is, that is ROC. So it is ripple carry out. So ripple carry out, it's mean, so the ROC is high when the counter reached its maximum count 111. Then in binary in binary or in decimal, that is 15. So ROC can used to cascade the multiple 74LS163 IC for extended counting range. And pin number 16 is that is 16 pin, that is for the power supply, that is plus 4 volt. So for this experiment I am using one another circuit, that is the pulse circuit that I am using for the 555 timer IC, and one 10 that is 555 timer IC, and one 1 microfarad capacitor, and yeah, and 1 microfarad capacitor, and 100 kilo ohm resistor, and 220 kilo ohm resistor. As you can see in the diagram, the written resistors may be different, because sometime you want to different pulse rate, so I have configured these things accordingly. But the diagram is same, but just I have to change the resistor value, and resistor value and capacitor value, and I will get accordingly what pulse rate I am want. So there is two method I am using. The one is to create a pulse from the 555 timer, and second is to using the ADLM channel, ADLM channel A. So yeah, and this you can see here is the circuit. This is IC 74LS163, and as you can see, these are the LED that you can see the blinking, how the counter IC works. And yeah, I am using these resistors, that is 220 ohms resistors. And yeah, this one is inverter IC. And yeah, you can see how LED blinks. Yeah, you can see this one is 15 and this one is 0. Now you can see it started one counting less, and this one is 2, this one is 14, that 13, you can see here. Yeah, you can see it's working fine. And here is the top view of my circuit, as you can see, where I connecting these wires, and I mentioned the how 1110 and 0001, as you can see in this. Yeah, so that is the experiment of week 3. And thank you.